about this lovely genus, Poeciloterpa, that few of you have been finding yesterday on Mount Makiling. This genus is endemic to the Philippines, and so we've been seeing it yesterday. It's a genus that everything started with a revision with when Elord Crespolen started his PhD studies in Paris with us. And so we've done some traditional revision of the genus, and we described a few new species that are illustrated here on this slide. We've done as well, along with it, we tried to provide a useful key, a dichotomic key, in order to identify them. We had small work as well with a student, Marie Porcher, and she done for us a digital key available on the internet if you want to try it. And the good thing about this kind of digital key is that you start with whatever character you feel comfortable to use to do your identification. And here, for example, if you think that you can recognize anything on the wings, you select this character on the wings, see the character, click the one you're observing, and then the good thing is that automatically, when you have chosen the character you're interested on, it discards all the taxa that are not bearing this character. And at one point of your identification, you are stuck. At least you have a reduced list of insect of species available. So that was part of our work for the Poeciloterpa, and we went on with a lot of work on the molecular phylogeny of the CERCOPIDAE, in which the Poeciloterpa are part of, and the Poeciloterpa are nested in this part of the phylogeny, which is the group 2, which remain in true CERCOPIDAE point of view. And here they are. It's a nice little monophyletic genus, apparently, nested in this group of CERCOPIDAE. So from this moment, we started to ask ourselves further question on the group, knowing especially that we've been able, as you can see in the distribution of the archipelago, that Poeciloterpa was found in Mindanao, in Luzon, in Negros, but some islands are missing. Missing why is the insect present in there or not? We don't know because we haven't visited them yet. So that could be a nice work to do, collecting around those islands to check if they are living there and if there are other species of the group living on the, for example, Palawan island. And since we had collected quite a few data for the distribution of the genus, we started to ask ourselves a few questions. Since the Poeciloterpa are xylem feeder and supposed to be generalists, that their actual distribution could be mostly explained according to the climatic condition, and if in the future what's going to happen to those insects with the climatic changes, how those information will be enough to explain their future distribution. But if it's the case, we can expect as well their distribution to be greatly affected in the future due to climatic change. But since they are not specialized on the host plants, could they switch to other host plants in order to stay and live in an island? If it's the case, the deforestation and the use of the land and the climatic change in there. A switch of host plant could be a possibility. And that is a bit scary, especially then since we know that some CERCOPIDAE or HEMIPTERA have been able to use the crop grown by human beings. So some pests are pretty well known, like marana in Latin America, where it's responsible for damage on sugarcane and quite a large reduction of the productivity there. Qualitative versicolor in Asia is a pest on rice and maize. So it could be a scenario possible for Poeciloterpa in the future. What do we know about Poeciloterpa and the host plant of this genus? Thanks to Sheng and to Elord, we have at least 4 host plants known now. We have Heliconia, which is a plant that is not from the Philippine archipelago. It's coming from the tropical America. We've got Gioio, which is a Malvaceae, and it originated in Southeast Asia. We've got the genus Shorea, which is a native Southeast Asian plant found from India to Malaysia, Indonesia, and the Philippines. And the last one, the Melastoma, that I took a picture yesterday on Mackay, is found as well in Asia and is known by 100 species distributed in Southeast Asia. What do we know as well about Philippines and the context in which we found those insects there? We know that actually 7 million hectares of forest are present on the archipelago, and that we know that due to loss of forest for the forest extraction and the use of agricultural land, it's not something that is going to stop. And actually, the main crop in the island are the production of rice and sugarcane. So then we decided to start this niche modeling. For that, you need to have enough points of distribution of your taxon that you are interested in order to start it. We didn't have enough distribution point for each of the species, but we made the assumption that since the Poeciloterpa species are living in the same environment, in the same biotopes, we could enlarge our study to the genus level. And at the genus level, we've got enough points to start this kind of study. And we know that Poeciloterpa are found mainly in forest, wet forest, and on the edge of them. For this modeling work, we needed to have a certain number of bioclimatic variables, and from the 19 bioclimatic variables available on WorldClim, we did select 10 of them. And we passed on the how we did select them. Here, it's the boring part of it. Then we had to select as well the bioclimatic variable that will be used for modeling in the future what's going to happen to our insects. And those information, we got them from the Climate Change, Agricultural and Food Security site. We decided to make a projection towards 2080 to have something, to get a bit of a depth into the our projection. And we decided to select one scenario possible. What are those scenarios? Knowing that global warming is going to have an impact on our environment, and that we are emitting greenhouse gases, depends on how we are going to be able to control the emission of these greenhouse gases. The future will be different. If we are able to control it by the 2100, then it's an optimistic scenario and if we don't get any control, whatsoever we are doing on emission of greenhouse gas, that we are taking a little bit of this path at the moment, it's going to be a more drastic condition by the time we reach 2018. So we decided to do our modeling according to this worst situation. Then we decided to as well to do two kinds of niche modeling. One in which we imply that is only the bioclimatic variable that are going to impact our insect. Generally, in the literature, it is said that in this case we are going to overestimate the right condition and for the taxon studies. And so we decided to as well, since we know at least 4 host plants for this genus, to introduce the host plants as a variable as well. And so the second modeling includes the bioclimatic variable and the plant distribution. In this case, it is generally said that we underestimate the niche for the taxon, since we have got only a reduced number of host plants. You don't get them all known and all included in your model. But first, then, since we decided to use this 4 host plants, we had first to do the ecological niche modeling for those plants. And we went into the Global Biodiversity Information Facility, the GBIF, in order to get the distribution of those host plants and to get their coordinate in order to plot that on a map. And we get 42 specimens of Heliconia registered into this database with their coordinate, 54 for Durio, 118 for Melastoma, and 584 for Choraya. And here, then we got on the island of Philippines, how the host plants are going to be distributed and where are the suitable area for the host plants. And as you can see there on the 4 graphic, is that the distribution of the plants are pretty different from each other. You can see that a Melastoma or Choraya got a wide distribution, with especially Choraya pretty present in the north of Luzon, on this island. And if you compare it with the distribution of Durio, you see that it is far more constrained to the south of the Philippines, in Mindanao, for example. Or if you take Heliconia, it is found in Mindanao and as well a little bit in the Luzon. Please keep in mind that that is quite widely distributed in the island, and that they got different patches, and that make in fact quite a large suitable area for Poeciloterpa to live on a host plant point of view. That will have an impact probably on our result later. So here we go. That's the first niche modeling, in which we use only the bioclimatic variable, and for the present day, to get the suitable area for Poeciloterpa. The more green the spots are, more suitable the area is for living for the genus. And more you are going toward the gray, more it's less suitable. And we can see that on these 2 modeling, in fact, we've got quite a surprising result that went to opposite way of what we generally said, that the modeling is more constraining when you introduce the host plant, and here it's the other way around. You can see on the figure on your right side that the distribution possible in, for example, in Luzon is wider than it is when you take only the bioclimatic condition to explain the distribution of Poeciloterpa. Now, if we extrapolate in the future what's going to happen to Poeciloterpa toward 2080, you see that the area suitable for this genus shrink quite a lot, and even is getting very, very not suitable for them when you introduce the host plant information into the model. So, what could explain such a distribution in the end in 2080? If you compare an orographic map with the map in which the host plants are important for the Poeciloterpa, you can see that the remaining area where you could find Poeciloterpa are only found in places where you go to mountain and when you can get into altitude. And that is probably that would happen to the genus. It will follow their host plants that will need to go up into the mountain to remain living when the global warming will do its job. So what's next? Because that was only a little start for this niche modeling. We would like to have some variable explaining the vegetal cover. It could be included into the variable, and that could be a good indicator to give the ideal vegetal density for the Poeciloterpa to live. But as well, it could give information about the deforestation effects. However, for the moment, we were not able to do it because we couldn't get the data. Then a second thing would be interesting to do, since we maybe suspect that in the future, in order to leave Poeciloterpa could switch host plants, it would be interesting to know how a host plant like sugarcane could be distributed, and if you could see the map of distribution of the sugarcane and compare it with the niche modeling of Poeciloterpa, if there are some part of it that are overlapping, so when the condition gets more extreme for the insect, then it could move directly on the sugarcane. But this kind of information is not accessible for the moment because it's reserved to the internal study and analysis of the archipelago. So, but we hope that maybe Elord will be able to get this kind of information and carry on with the niche modeling, so we could see what's happened if we introduce sugarcane into the model as a biotic variable. So the only information we could get, it was the actual statistic about where roughly the sugarcane production is in the Philippines, and the main island where you can find sugarcane, it is in Negros, Luzon, and in Panay. And I placed on the right side the two modeling situation, the present situation and the future situation for Poeciloterpa. And you can see that the insect is having some contact, at least in the island of Negros and Luzon. And if you go in Negros Island, you can see this magnificent Canlaon mountain, and you can see at the feet of it sugarcane field, and you can collect Poeciloterpa into the mountain. So here there are some point of contact in between the insect and the sugarcane, and so it's something to be watched in the future, because Poeciloterpa, if it wants to survive in the Philippines, at one point of time, maybe it won't get the choice. It will have to try and test other plants, and maybe it will go onto the sugarcane. Thank you very much for your attention.